Welcome back. In today's video, we will learn how to use SPSS to run analysis on paired sample t-test. Meaning, paired sample, we have two means in terms of two different variables. How can we estimate if there is a significant difference in their mean? Of course, this is very much appropriate using SPSS. Variables such as having a data set and you have collected the data on a variable, and of course you collected a subsequent data. You can use paired sample t-test to test if there is a significant mean difference between the first data set you've collected on a variable and the second data set you've collected on a variable. So let's open our SPSS interface. You see we are using a data set, and let me quickly tell us about the story on this data set. We have data set on grades, we have pre-test, post-test, GPA, income, and the rest. And in this data set we realize that we have pre-test and post-test. In between these two, there was an introduction of a program which enables students to have access to the internet. So the first data set, pre-test, was collected before the introduction of the internet to the students. And thereafter, after the introduction, a post-test was conducted on the students. So we want to find out, using the paired sample t-test, if there is a significant mean difference between the first set of data collected, which is the pre-test, and the second data collected after the internet availability, called the post-test. To conduct this, just go to the SPSS Analyze icon. You click on Analyze. Go to Compare Means. Under Compare Means, you have many options. Scroll down to Paired Samples t-test. Then you click, and this box will come up. We are estimating for two variables. We have pre-tests and we have post-tests. Now we click OK. You can go to your output windows to see the results. Here's the result of the SPSS paired sample t-test analysis. We have the first table here talking about the mean of pre-test and that of post-test. Even from this, you can realize that the mean has increased. For pre-test, it was 79%. Now, for post-test, it's 83.52%. And of course, the correlation is very high at 0.855. That's a strong positive correlation, which is statistically significant. Now, going to the paired sample test results. Now we have the t-statistics. We have the degree of freedom, and we have the significance level, 5% significance level. The t-statistics, the result is minus 3.82, while the significance level is 0.001. And of course, this is statistically significant, meaning that we can conclude that there is a significant mean difference between these two sets of variables, meaning the introduction of internet to the students has really helped them to increase and to perform better. And this is shown via the significance level. And of course, you can also interpret this from the basis of the t-statistics, which is what? Minus 3.82. From here, we realize that it is negative. But in comparing it with the 5% significant level, which is 1.96, we need the absolute value of the t-statistics. So the absolute value of minus 3.82 is 3.82. And the decision rule is that for us to reject the null hypothesis, to accept that there is a significant mean difference, the absolute value of the t-test should be greater and must be greater than the significant level at 0.05, which is 1.96. So 3.82 is greater than 1.96. So, and this tallies with the significant level as estimated, which is 0.001. So we can conclude that our result is statistically significant. Therefore, we can infer that there is a significant mean difference between the two variables used, that is pre-test and post-test, meaning that the internet access given to the student has really improved their academic performance. Thank you. I'll see you in the next video.